In this experiment, we're going to measure the average speed and the instantaneous speed of a ball bearing going down a ramp. And you can see this is the ramp here, it's on its side at the moment, and it's got a ruler built in. So I'm going to allow the ball bearing to fall from 0 on here, and the length of the ramp is 1.5 meters. So I'm going to allow the ball bearing to roll down the ramp, and I'm going to measure its speed at the top, in the middle and at the bottom, and I'm going to compare that with the average speed. So obviously the speed is changing for the ball bearing, and at the top the speed is 0 meters per second, but at the bottom it will have accelerated to quite a high speed, but it won't have maintained that high speed all the way down the ramp. So the instantaneous speed of the ball bearing might be 0 here, it might be 1 meter a second here, and it might be 2 meters a second here. So the instantaneous speed is going to be different to the average speed. To measure the instantaneous speed, I'm going to use this device here. This is a pair of light gates built into here, and when the ball bearing breaks the beam, it starts a timer, and when it breaks the beam, it stops the timer. And if we, by knowing how far apart the beams of light are, it can work out a speed and give you that directly. So to start off with, I'm going to place it halfway down the ramp. So I'm going to place it so that it is at 75 centimeters, which is halfway down the ramp. And I'm going to measure the speed of the ball bearing at that point there. So switch on. And the light gate reader gives me a speed of 1.02 meters per second. So I record that on my table. Now I'm going to repeat the experiment because it makes my results more reliable. So if there is any anomalies, for example, if I'd given the ball bearing a little push or accidentally changed the height, that should become apparent because the time would be very different. And on my second reading, I get 1.01 meters per second. Third time. And I get 1.01 again. So I can average those three speeds out. I'm now going to place the light gate at the bottom of the ramp and measure the speed at the bottom of the ramp. And I have a speed of 1.40 first. .40 and 1.41. So I now have my results, and I can average these results out so I can find the instantaneous speed at the top, in the middle and at the bottom. And I'll be able to use those to compare it with the average speed, which I'm going to calculate now. To calculate the average speed, I'm not going to use a light gate. I'm going to use a stop clock. To find the average speed, I'm going to time, using a stop clock, the time it takes the ball bearing to go from the top to the bottom of the ramp. And I'm going to repeat that 3 times to get an average time. Once I know the time and I know the length of the ramp is 1.5 meters, I can work out the average speed of the ball bearing. So as I release the ball bearing, I'm going to start the stop clock, and when it reaches the bottom of the ramp, I'm going to stop it. So my first reading is 1.96. My next reading is 2.1. Notice these readings are very different to the first set of readings using the light gate because I've now introduced human error. So I've got a reaction time. Each time will be slightly different. Let's do it a third time. And I get 1.94 seconds. So I've got my 3 times here. I can average those out to find and then use that to find the average speed going down the ramp.